All right, guys, I got your questions about the video, your feedback. The video was not letting you skip to roses, so I'm just gonna make my own roses video, okay? All right, so if you already took notes, take more notes, because I promise I'll have more insightful information than the video people. Okay, so for roses or flowers, well, they're basically like circles, except now you're gonna have a number that is inside next to the theta, and that's your B value, and that's going to indicate the number of petals your flower or rose will have. Okay, so you have R equals A sine theta, or we can have R equals A cosine of B theta. And you know what? Let's stick to the format we did last time, where I do sine on one side and cosine on the other side of a chart. All right, so A gives you the length of the petal. Okay, and B gives you the number of petals. For both sine and cosine, if B is odd, then you will have B many petals. But if B is even, then you will have twice as many petals. Okay. Your symmetries are still true. So for sine, okay, so wait, so these are some fun facts. Let's separate these somehow. That's there you go. Because I still want you to make some flashcards. You should put both of these things for both of them, or all three things here. But for sine, let's look at an example of a sine graph. So let's say we had something like, let me look for one. Let's say, all right, let's say we had 4 sine of 2 theta, okay? So sine will have symmetry with respect to the vertical axis still. And sine will not start at the polar axis. So sine starts always somewhere else. Okay, and I'll go over examples as to how to do that. For cosine, let's say you had 4 cosine of 2 theta. It's the same thing, except now the petals do start at the polar axis. Okay. Okay, because it has to do with, sine starting at equilibrium when on your helper graph, right? Your helper graph, and cosine starting at the max. So cosine starts at the max here. All right, so then A is the length of the petals, right? B is the number of petals. So if it's odd, then it's B many, and if it's even, then you're going to have twice as many petals. Okay. And yeah, the symmetry still work. So let's look at an odd one. Let's look at like 3 sine of 3 theta. Okay, so if it's odd, then sine will have symmetry with respect to the vertical axis still, okay? But you have to divide 360 by the number of petals you're going to have, and then that's how far apart they are. And I'll show you more detail about how to do this. These are just like little samples here that you can keep and write down, and then we'll go over more in detail how you would get started. But if it was like 3 cosine of 3 theta, it would start at the max and then have symmetry with respect to the polar axis. Not the, yeah, is that the horizontal? Yeah, the polar axis. So this is kind of like the overview of it, okay? Let's look at an example. So let's look at example 1. Let's say we had something like 5 cosine of 3 theta, or sine of 3 theta. Okay, so it's r equals that much. So what you want to do is you want to start with your helper graph. Okay. So your helper graph is y equals 5 sine of 3 theta. And look at the period. The period is 2 pi over b. So here the period is 2 pi over 3. Okay, and you have your midpoint, so pi over 3, your quarter point, and your third quarter point. So 1, 2, 3 pi over 6, which is pi over 2. So then you have a max of 5 and a minimum of 5. So sine starts at equilibrium and then goes up and down, right? What you want to do for these, you want to go all the way to 2 pi to see how many cycles you're going to have. Okay, so let me see. So here I'm at the bottom, so if I was going to go a full cycle, so 2 pi over 3, 4 pi over 3, and 6 pi over 3. Okay, that gets me to 2 pi. And I have a full cycle in between. So full cycle, full cycle. Okay, so I'm going all the way to 2 pi here. So here's my graph. I need to have at least 5 tick marks for my R value, my A value, the length of the petal. And look at all of the maxes. Look at where they happen. At pi over 6. Look at the min at pi over 2. Those are important. That means that at pi over 6 and at pi over 2, I'm going to have leaves. At pi over 6, my R value is positive, so I'm going to have a petal at pi over 6. And then at pi over 2, my R value is negative, so instead of going out 5 units, I'm going to go in 5 units, okay, at pi over 2. And then again at whatever this point is. And you can do the math and you can do fractions and figure out what that is, but I'm gonna use symmetries. Okay, so again, to recap, from 0 to pi over 6, my R value is increasing and it decreases again. And then from pi over 3 to 2 pi over 3, it's getting negative. So that's how I get that leaf. And then I can figure out what this point is just by using quarter points. So 1, 2, 3, 4, 5 pi over 6. But something else you can do is you can use symmetry. You can say, okay, 3 theta, I'm going to have 3 leaves in within 360 degrees, and we use degrees because we know those better. So that's 120 degrees apart, that's 120 degrees apart, and that's 120 degrees apart. That's 2 pi over 3 apart, if you want to do the fractions there. You just have to add 2 pi over 3 to pi over 6. To get the next leaf. And you get 5 pi over 6, and that's how we get that leaf that's there, okay? Or you can use the helper graph. I think at some point, the goal is for you to stop using the helper graphs and be able to just do these by hand. But, next year in BCE or in 2 years when you take Calculus 2, it's okay. You're going to just look at the graphs and quickly look at a graphic organizer to remember these. Okay, so right now I'm just teaching you where they come from. So it's important that you know why we're not starting over here, right? Because the graph doesn't start at the max, starts at equilibrium, so it starts at 0. So it's important that you know the why right now. Okay, so let's do one more, and then and that's it. So let's do a cosine. I printed some here. What's a good one? Okay, let's do a 5 one. Yeah, let's do this 5 theta one. Okay, so A is 6, B is 5, so we're going to have 5 petals, okay? And then we're going to do a hypergraph. So 6, the period is 2 pi over 5. Oh, man. So 4 pi over 5 and 6 pi over 5. Oh, it's going to have a lot of cycles. Let me rewrite this because I did say go to 2 pi. Now you don't have to. I'm not gonna make you, um, but it's helpful if you see like how many petals. So yeah, there's probably gonna be like 5 of these, right, for us to get to 2 pi. So we'll keep going. Okay, so we have 5 petals, max is 6, minimum is -6. Cosine starts at the max and goes down to the minimum and then back to the max. So then this point here is pi over 5. So this point here is pi over 10. Okay, so look at where we get the first leaf at pi over 5. Okay, so that means that here's pi, I should split the first half of the circle into I should split all of it into 5. So 2 pi over 5, or in degrees, it would be 360 divided by 5, right? So how many degrees is that? Well, divided by 10 is 36, so twice as many, 72 degrees. So every 72 degrees, we're going to have a leaf. So I know this is 60, I know this is 90, so 72 is probably something somewhere over here. Okay, so I like to draw some dashed lines. And Mrs. Stratus, do we have to stick to radians, degrees, and whatnot? You know what? It doesn't matter. You can mix it up as long as you're consistent. Okay, if you want to go to degrees. I mean, you want to stay in radians because that's what you're going to use in calculus. But for intuition, for drawing these things, if you want to do 72 or 2 pi over 5 here, I'm not going to take off points for that. Okay, so that's your first leaf. So then we're going to add 72 to get the next leaf. Okay, so 72 plus 72. And then we get the next leaf at 144. So I know this is 135. So 144. No, wait, is that one? That's 150. Mr. Honest. Okay, so that's 150. So then 144 is somewhere over here. Right? So this is going to be 2 pi over 5. And we keep going. So we're going to keep adding 72 degrees. Okay, so plus 72. And we get 216. So this is 210. So 216 is somewhere over here. So we're basically dividing the circle 360 into 5. Okay, so the next one, plus 72. We get 288 somewhere over here. So this was 216. And in radians, we're just going by pi over 5. So pi over 5, 2 pi over 5, 3 pi over 5, this is 4 pi over 5. And then 5 pi over 5, 4 pi over 5. And then 5 pi over 5, look, is somewhere over here at plus 72. We're back at 360. Okay, so, but isn't 5 pi over 5 just pi? So what am I doing wrong here? 0, pi over 5, 2 pi over 5, 3 pi over 5. 4 pi over 5. That doesn't make sense. What am I not seeing? 72. 288, 360. What am I not seeing? I'm not seeing something. So 0, pi over 5. Well, I'll come back to it. There's something I'm not seeing. I'm messing up somehow. But anyway, I mean, I'm messing up with my counting of radians somehow. But I'll stick to degrees. See, so. Okay, so then just draw my flowers. Whee! Okay, and it's the same thing here. You would keep going and draw your flowers. So you can keep going on the graph, but for 5 or more, I'm not going to do a helper graph. That's way too many cycles to go all the way to 2 pi. I would go to 8 pi over 5, 10 pi over 5, and then have a full cycle like so, and figure out where my max and mins are. So like at pi over 10 and 3 pi over, that's too complicated. I like the way I did it better, where I just take 360, divide by the number of petals. Definitely like start the helper graph with one period to see where you start and where the first petal is going to be. And then after that, use symmetry. So that's what I would do for these multiple ones. Okay, so that's it for today. I'll see you guys next time, and next time we'll be live. So bring your questions, annotate your notes, do your flashcards. See you later.